Okay, good morning class. Today we're looking at the St. Susie paper 2. This was last year's paper. This is grade 8. So at this point you guys have completed the paper. So we're just going through the explanation here. Okay, I didn't cut it. Okay, so in question 1 we are told to calculate the value of x and y, x, y and z in the diagram below. Provide the reasons for your answers. Okay. So how do we calculate x? Okay, we angle on a straight line. Not so. Some windows, please be don't mind. The angles on a straight line. So we've got 60 plus 40 plus x is equal to 180. As you see, this angles on a straight line. So x equal to 180 minus 60 minus 40, which is 80 degrees. Okay. Next. Are you going to calculate y? Will you agree with that? The alternate angle. Okay. So y is equal to 40 degrees. As you see this, alternate angles. So there's no label or there's no letters on the vertices. So you don't have to say which lines are parallel, of course. Okay. So I'll put 40 here. Now what? How do you calculate z? Sum of triangles. You can say that 40 plus 60 plus z is 180, sum of triangles, or corresponding. So no calculation you did. Both will get you the full mark in you, provided you make no mistake in your calculation. Okay, so that's going to be 80. So z is equal to 80 degrees because it's alternate angles. Sorry, corresponding angles. The f is corresponding, so it's corresponding angles. Okay. Any confusion there? Right. In triangle ABC, calculate with reason the size of x. So you solve for x here. Sum of triangles. Okay. I'm going to say 52 degrees plus 44 degrees plus 3x minus 15 is equal to 180. Why? Sum of triangles. This triangle ABC. You don't have to say the name of this triangle. Okay. So we now say 3x is equal to 180 minus 52 minus 44 plus 15. So 180 minus 52 is 128, yes. Minus 44 is 4, it's 84, correct? Plus 15 is 9, 99. Is that correct?
Yes, sir.
3x is going to be 99, so x is going to be 33. Okay? Any confusion there? Next, calculate with reason the angle marked x and y. So how do you calculate x? Angles on a straight line. So x plus 130 is equal to 180. Straight line. Okay. So x is equal to 180 minus 130, which is 50 degrees. Okay? I'm going to calculate y, sum of triangles, because I know x is 50. Or I could have said exterior angles equal to sum of the two interior opposite. Okay? 130 is equal to y plus y minus 20. So you're going to say 50 plus y minus 20 is equal to 180. Sum of triangles, and this triangle ABC. So it's going to of course give us 2y is equal to 180 minus 50 plus 20. It will be 2y is equal to 180 minus 50 is 130. 130 plus 20 is 150. Divided by 2 both sides, so y gives us an answer of 75 degrees. Okay, any confusion there? Okay. We're moving too fast. Okay, determine the value for x where DE is parallel to FG. Provide a reason for your answer. So what do you notice here? Corresponding angles. Not so. So we're going to say that 2x minus 30 is equal to x plus 20. Why? It's corresponding angles with DE being parallel to FG. Okay. Solve for x. So you're going to be 2x minus x is equal to 20 plus 30. What is 2x minus x? Equals 30. Okay. Find A. Find the value of A. So what can we say here? Vertically opposite angles are equal. So 3a plus minus 10 is equal to 30 minus a. It is vertically opposite angles. Okay. So in pursuit of calculating a, I must do your linear equations. So you got 3a. You bring minus a over becomes plus a is equal to 30 plus 10, which is 40 equals 4. I don't get a on its own. Divide by 4 both sides. So a is equal to 10. Okay. Now we're going to question 2. Match the description given in column B with the name of the shape given in column A. Trapezium. What's the properties of a trapezium? It has one pair of opposite sides parallel. Alright. Opposite sides parallel equal now. One set of sides parallel, yes. So that is B. Not so. Alright. A rhombus. There are 5 properties of a rhombus. What's the properties of a rhombus? All sides are equal. 2 pairs of opposite angles are equal. 2 pairs of opposite sides are parallel. Diagonals bisect each other. Diagonals are perpendicular to each other. The fifth one is diagonals bisect the vertex angles. Okay. Now there are of these properties that is also in a parallelogram. Not so. And in a square and so on. So you must just be careful here. Okay, so we say opposite sides parallel and equal. It could be the case, but that is also on a parallelogram. Not so. So I would say that is a parallelogram. Okay. Adjacent sides are equal. Yes, that could be a kite or a parallelogram. Not so. But it fits. The least this can be is a kite. All sides are equal and parallel and all angles are equal. Square. all sides are equal and parallel. It's not actually not all the sides are equal and parallel. All sides are equal and opposite sides are parallel. Because is all the sides parallel? No. So it should have been all sides equal and opposite sides are parallel and all angles are equal. So that is going to be fits the best the square. All sides are equal and opposite sides are parallel. That's the rhombus. I think you just forgot to put opposite, no? In both cases. You all agree with that, people? Any confusion? Alright, let's go. 2.2. Look at the figure. JKLM. Provide the reasons for your answer. What type of quadrilateral is JKLM? It's a parallelogram. Why? Two pairs of opposite sides parallel. People, that opposite sides are parallel in four shapes: a square, a parallelogram, a rhombus, and a rectangle. No? But the least it can be, it is a parallelogram. Okay, it could be as it is tilted, it could be a rhombus as well. But we need to have been told that all the sides are equal. Even though if it had looked equal, okay, here it's clear it's a parallelogram. Even if it had looked equal, I would have still said it's a parallelogram. Why? Because the sides was not given equal. You guys understand? So it's a parallelogram, and the reason for that is that opposite sides are parallel. L, what's the size of angle L? The angle L is 150 degrees. Why? Opposite angles are equal in parallelogram. Okay. Next, calculate the value of x. Provide the reason for your answer. I'm going to solve for x. Sum of 1. Okay. So I'm going to say 66 plus x plus 90 plus 90 equals 360. Why? So it's the interior angles of a quad. Okay. Or sum of quads anyway. So that's going to give you x is equal to 360 minus 90 minus 90 minus 66. Okay. So that's 180. So 180 minus 66 is 114. Is that correct? Could I have said that 66 plus x is 180? Co-interior. Could I have said that? No, why not? We weren't told the lines, even though the lines are parallel, we weren't told that the lines are parallel. So I can't use co-interior. Unless I prove that the lines are parallel, then I can go with co-interior. Okay? We're not at that point yet. Alright, let's look at question 3.1. Given, so here we're given a semicircle and a triangle, a right angle triangle in the semicircle. People, what do we know about the right angle triangle? We can use Pythagoras, not so. It says use the rule of Pythagoras to find the diameter of the circle. So how do we, the diameter is AC, not so. So I'm going to say AC squared is equal to 5 squared plus 12 squared. Reason? Pythagoras with angle B equals 90 degrees. So that is AC squared is equal to 25 plus 144, which is 169, not so. So AC is going to give you 30. Or you can just say AC is 30, and you can just say Pythagorean triple. Okay. So 3.1.2, calculate the area of the triangle. How do you calculate the area of a triangle? Of base times perpendicular height. Not so. So you're going to look at of, so what's going to be your base here? 5 and your perpendicular height? 12. It's not going to be 13, no? Because it has to do with the 90 degree sides. Sides that is to do with the 90 degrees. So area of a triangle is half base times perpendicular height. So it's half base is 5 times the perpendicular height is 12. 6 times 5 is 30. Is that correct? 30 centimeters squared. Okay. Let's go to the next question. Is that it? There are more questions here. There's only these 2 questions for. Yes? Is there a 3.1.3? No. Okay, I would have asked this question as well if I said this paper. Calculate the area of the shaded region. Yes? Same. Okay. I would ask you, it's not asked yet, but to calculate the area of the shaded region. Okay. So how are you going to calculate the area of the shaded region? So which shape is the bigger shape? The semicircle or the triangle? Semicircle. So I'm going to say the area of the semicircle minus the area of a triangle. The area, no? So how do you calculate the area of a circle? Pi or square. So I must divide it by 2 because I am semi. No? Or multiplied by half. It will be pi r squared multiplied by half minus half base times perpendicular height. But this area I got already. What is the size of that area? 30. So it's going to be 22 over 7 multiplied by. So if the diameter is 13, what's the radius? 6.5 or 13 over 2. Squared times a half minus 30. You see that, people? Then from there, I just go and calculate. Okay. So you're going to say 2 goes into 1, so 2 going to the 11 times. So it's going to be 11 times 2. No. So it's 11 over 7 multiplied by 169 over 4 minus 30. Okay, and then from there, just some multiplication and whatever you need to tidy up. Okay, you guys understand? But the numbers are fairly large, so I would have used probably smaller values here. Okay, because you guys will not be using a calculator. We will in the diagram below, PQ is equal to QR. Now if PQ is 15, what is QR? 15 as well. Calculate the length of PR. Leave your answer in circle. PR, this is going to be this length. Now people, is this PRQ a right angle triangle? No. So I can't use that thing. However, if I look at what I have here, what side can be actually calculated at this point? Yes, QP is, you got 15, you got 9, you don't have, is QS. Can you see that? In this right angle triangle, I got 9, I don't have is R, and I don't have that D. Not so. So what can be calculated at this point is Q. Not so. Again, you don't have to write this. You can, I'm saying intra-angle PQS. Again, you don't have to write that. No? So what can I say about this triangle here? What's the hypotenuse? 15. So I say 15 squared is equal to 9 squared plus QS squared. The reason? Pythagoras. Can't just say angle is. PSQ equals 90. Okay. So it's 225 minus 81 is equal to QS squared. So QS squared is equal to, what's 225 minus 81? Sorry? 144. The square root of that is 12. So QS is 12. Now what? SR I can work out at this point. So SR is equal to 15 minus 12. Y is given that PQ is equal to QR, which is equal to, that's your reason is given. Why must I write that? Because it wasn't given on the diagram. Okay? And what is 15 minus 12? 3. Yes?
Did you say QR is equal to 15 because QB is equal to 15?
Yeah. It was given there. Okay, yes?
If we write that first,
Before?
yeah, to that begin.
No. Once is enough. Anything else? So with that now I should be able to work out PR. No? So in which triangle am I working now? In triangle PSR. I can say PR squared is equal to 9 squared plus 3 squared. Reason? Pythagoras with PSR equals 90. 9 squared is 81 plus 9, which is 90. So how do we get PR on its own? Square. Is 90 a perfect square? No. So therefore, PR is equal to the square root of. Okay? Any confusion there? Still got a lot of questions. Study the shape below and answer the question as follows. Calculate the perimeter of the shape. Remember, you must start here. It's going to be 10 plus 9 plus 6 plus. Now, if that length is 20, that is 9, so from there to there is also 20. Not so. So, if this is 9, this has to be 11. If that is 9. 11 plus 9 is 20. Okay, plus, if this length here is 10. Not so. And if this is 6, this would be 4. Plus 20. Okay. Summing up now. Open. Right, boost. I thought you were sitting. Somebody looked just like you. Okay. So this is going to be 19, 30, 40, 60. Is that correct?
Yes, sir.
60 centimeters. Okay. Calculate the area of the shape. Right, how do you calculate area? We will have to divide it into basic shapes. And it's divided there. So the area of this, the total area will be the area of the square. How do you calculate the area of not the square, a rectangle? Length times breadth. So this would be 9 times 6 plus length times breadth. Yes, it will be 20 times, not 10. There's only that length here, so it's 4. You guys understand? 9 times 6 is 54 plus 80, which is 134 centimeters. Is that correct? Huh? Okay. Next, you're given a semicircle, diameter of 280 millimeters. Determine the length of the wire required to make a frame of a semicircle with diameter of 280, where pi is 22/7. People, the perimeter will be that length from there around there, okay? How do you calculate the perimeter of a circle? Or the circumference of a circle? 2 pi r. So it's going to be 2 pi. And what's the radius here? Remember, the radius is going to be half of the diameter, not so? So it's going to be 280 divided by 2. It's 140. So from there to there is 140. Okay, so it's going to be 2 pi r plus this length on this. It's not so. But I must divide this by 2. Why? Semicircle. So of course that cancels. So what is pi? 22/7 multiplied by r. 140/1 plus the length of this is 280. Okay, so that gives us 7 going to 7 1, 7 going to 140. Sorry? 20 times. So 20 times 22 is 440, is that correct? Plus 280. So it's going to be 720 millimeters. Is that correct? Any confusion here? You see, when we give you without the calculator, we tell you something like this here, and the numbers is normally nicely divisible by the R value. We all values divisible by 7 normally. Okay. Alright, next, calculate the area of the shape below. People. So what do you notice? What the basic shapes do you see here? A rectangle, yes? And 2 semicircles. We put 2 semicircles together, what do we get? A circle. So area, the total area would be the area of this rectangle, measuring 102 by 102 by 42. Not so. You must add the area of a circle. How do you calculate the area of a circle? Pi squared. And what's the radius of the circle from center to circumference? What's the radius? 21. Okay. So how do you calculate the area of a rectangle? Length times width. Not so. Plus the area of a circle, pi r. So the length is 102 times 42 plus pi is 22/7 times the radius 21. So 21. Okay, so now we go 102 multiplied by 42. So it's going to give you 204. 0804. If you add it, you get 4824. Okay? 4284 plus. Now 22/7 multiplied by 21 squared is 21 times 21. Not so. So 7 going to 7 1, 7 going to 21 3 times. 3 times 22 is 66. So that's 66 times 21. You will agree with that? So 21 times 66 is going to give you 6. 2 is 12. No? 0. 6, 12. So 6831. Is that correct? 1386. Just give me a total of 1386. So it's going to give you 10, 16, 17, 5, 6. So it's 5, 6, 7 now. Meters. Who got that answer? Alright. So I still can do one number you said. Any confusion? Okay, since most of you got it. The question paper and memo can be found in the description box below. Okay. Right? Okay, now you guys didn't do probability yet, no? And you guys only tested on it. So you guys did coordinates, Cartesian planes, and you did something else. Okay, so this section you won't be tested, but for the sake of the video, I'm going to explain anyway. Write down the probability of getting an odd number when you roll a 6 on the dice. So the probability is the number of favorable outcomes over the number of possible outcomes. Leave your answer in simplified fractions. So how many sides are there to a dice? There's 6 sides. So it's going to be 1, 2, 3, 4, 5, 6. So possible outcomes are 6. Okay. They want to know what's the probability of rolling an odd number. So which numbers are odd here? 1, 3, 5. So the probability is equal to the number of favorable outcomes over the number of possible outcomes. Okay. So it's simply going to be 3 over 6, which is half. You can either write it as half or 0.5 or 50-50.
Sir,
Yes?
how come if you just write the answer, this will get to know?
But yeah, this. Yes. I just wrote that down for explanation purposes. Okay, so one face of a cube is painted blue, 2 faces is painted green, and 3 faces is painted orange. People, how many sides are there in a cube? 6. So what's the name? All 6, no? One face is blue, 2 faces are painted green, and 3 faces are painted orange. Okay. What's the probability that you will roll the cube? What's the probability that when you roll the cube, the following will be on top when it lands? Huh? What is the probability that when you roll the cube, the following will be on top when it lands? Leave your answers. Oh, this. I'm thinking I'm going a bit crazy. Right, people, blue is on top. So how many outcomes are there? Possible outcomes. There's 6. How many favorable outcomes are blue? How many blues are there? 1. So it's going to be 1 out of 6. 5.2.2. Green. How many greens are there? 2 out of 6, which is 1 out of 3. 5.2.3. Not blue. How many blues are there? 1. Not blues are how many? 5. So not blues, will be 5 out of 6. Alright. Next one. The numbers 1 to 15 are placed in a hat. What is the probability of drawing a prime number? Leave your answer in simplified fractions. People, numbers 1 to 15 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how many possible outcomes are there? 15. There's 15 in the sample space. Not so. So you have 15. How many of those 15 are prime numbers? Is 1 prime? No. 2? The 2 is the only even prime number. What are prime numbers? Prime numbers are only numbers that only has 2 factors, 1 inside. Is 3 prime? Every other even number I'm not going to go over because 2 is divisible by 5? Yes. 7? Yes. 9? No. 11? Yes. 13? 15? No. So it's 1, 2, 3, 4, 5, 6. The probability is going to give you 6 out of 15, which is 2 over 5. As 3 can go into 6. 2 can go into 6. No, 3 can go into 6 and into 15. Okay. The bonus question. Given, what is 90 and 30? Determine the maximum number of circles with a radius 5 that can be cut out of a rectangle with a length of 90 centimeters and a breadth of 30. Okay. What did you guys get the answer? What did you get? We didn't get a formula. Okay. So firstly, the diameter is what we are interested in. Not so. So the diameter of this of one circle is 10. So how many circles of diameter 10 can fit in? 1 or 9 divided by 10 is? 90 divided by 10, sorry. It's 9. Okay, this diagram is probably not drawn to scale. But across here we can get 9 circles. Not so. So if I take 10 in this direction now, not so, so how many circles of the diameter 10 can fit down across here? 3. Can you see that? So it's 3 by 9. So therefore 3 times 9 is 27. So 27 circles with a radius of 5 with a diameter of 10 can fit in this figure. You all agree with that? You got that answer? Nice. Not everybody's going to get full marks on it. People, that brings us to the end of this paper. So you're going to choose another paper. Okay?